So in the previous homework assignment, we introduced in the video set the idea of linear combinations. We want to make that concrete now and show a couple of examples. So linear combination, here's what it is. If we have a vector space Rn, and from that vector space we draw n vectors, and then if we pick an arbitrary vector v from the vector space, if we are able to construct v from the n vectors that we have here using an appropriate choice of scalars, then we say that v is a linear combination of those vectors. In other words, if we can find n scalars such that scalar 1 times vector 1 plus scalar 2 times vector 2 plus all the way through scalar n times vector n adds up to or builds the vector v, then we say that v is a linear combination of those n vectors. So for example, we want to determine whether the vector 8, 0, 5 is a linear combination of these three vectors. So 8, 0, 5 is a vector space, is a vector from the vector space R3, and we've chosen three vectors from the vector space R3. We want to see, is this a linear combination of these three vectors? So if it is, then we can find a constant c sub 1 times vector 1, which is 1, 2, 3, right here, plus a constant 2 or scalar 2 times vector 2, which is 0, 1, 4, 0, 1, 4, plus we should be able to find a scalar 3 times vector 3, 2, negative 1, 1, such that this linear combination will add up to 8, 0, 5. So the question is, do such scalars exist? If they do, then 8, 0, 5 is a linear combination of the three given vectors. So to figure this out, you just distribute the c sub 1 into the first component, c sub 2 into the first component, c sub 3 into the first component, and that needs to generate the first component of vector 8, 0, 5. So c sub 1 times 1 is c sub 1, plus c sub 2 times 0 is 0, plus c sub 3 times 2 is plus 2c sub 3. And when we add the sum of the first components, that needs to add up to the 8, the first component of the vector we're working with. Now we work with the second component. C sub 1 times 2 is 2c sub 1, plus 1 times c sub 2 is c sub 2, plus a c sub 3 times negative 1 is going to be a minus c sub 3, and those need to add up to the 0. And finally, the third component, 3c sub 1 plus 4 times c sub 2 plus 1 times c sub 3 needs to add up to 5. And what we want to recognize here is we have a system of three equations in three unknowns, c sub 1, c sub 2, c sub 3. So we can just use matrix techniques from homework 1 to determine if c sub 1, c sub 2, and c sub 3 exist. So we'll just create the coefficient matrix. We have a c sub 1 column, a c sub 2 column, a c sub 3 column. We're going to get a 1, 2, 3 as the coefficients on the c sub 1s. We get a 0, 1, 4 as the coefficients on the c sub 2s. We get a 2, negative 1, 1 as the coefficients on the c sub 3s, and we augment it with the constant vector 8, 0, 5. And then now, but we can either by hand put this into reduced row echelon form, or we can have a computer algebra system put this into reduced row echelon form, and then we can interpret the results. So using GeoGebra, I put this into reduced row echelon form, and I got the matrix that looks like this. I got a 2, negative 1, 3. And so that tells us that c sub 1 equals 2, c sub 2 equals negative 1, and c sub 3 equals 3. c sub 3 equals 3. So we can conclude that 8, 0, 5 is a linear combination of the given vectors, because we were able to find scalars that worked. So the next example says determine whether 8, 0, 5 is a linear combination of these three vectors from the vector space R3. So it would be the same song and dance. We would say, hey, we're looking for c sub 1 times 1, 2, 3 plus some scalar c sub 2 times vector 0, 1, 4, plus c sub 3 times vector negative 1, 0, 5. And these need to add up to the vector 8, 0, 5. So we get c sub 1 times 1 is c sub 1, plus c sub 2 times 0 is 0, minus 1 times c sub 3 is minus c sub 3, and that needs to add up to 8. C sub 1 times 2 is 2c sub 1, plus 1 times c sub 2 is plus 1c sub 2, plus 0 times c sub 3, and that needs to add up to 0. And then for the third component, 3 times c sub 1, plus 4 times c sub 2, plus 5 times c sub 3 has to add up to the component 5. So putting this into an augmented matrix, we get coefficient matrix 1, 2, 3, 0, 1, 4, negative 1, 0, 5, augmented with 8, 0, 5. And then using GeoGebra Classic 5, I put this matrix, this augmented matrix, into reduced row echelon form, and I got 1, 0, 0, 0, 1, 0, 0, 0, I didn't get 0, 0, I got negative 1, 2, 0, augmented with 0, 0, 1. And then when we look at this, the important row is row 3, and row 3 has the claim 0 times c sub 1 plus 0 times c sub 2 plus 0 times c sub 3 equals 1. It's making the claim that 0 equals 1, which is false, so we know by row 3 there's no solution to the system, which means that the vector 8, 0, 5 is not a linear combination of the given vectors.